grade 10 functions. Question 5. Let's look at this question. The diagram shows the graph of G and F. R and S are the x-intercepts there. This is R and S. And then T is the y-intercept. Then F passes through R and T. Now on our diagram, is there anything that we can pick there? We can see that the y-intercept, that is the value of Q, is 8. These two graphs are sharing that one. So we are saying this one is an 8 there. This one is also an 8. And then we have these two coordinates. Remember, for the quadratic function, for the parabola, these 2 points are mirror images of each other, just that the other one will be positive and the other one will be negative. So we are saying here this is negative 2 because this is positive 2. Let's look at the questions and see what we can do there. Write down the range of G. This is your G. Your range is the Y values, that is starting from 8 going down to infinity. We write it as Y is less or equal to 8 because it is starting with 8 and 8 is included there. You could also write it as Y is an element of negative infinity to 8 with a square bracket. The equal sign is saying 8 is included. The square bracket is also saying 8 is included. Write down the x coordinate of R, that is this one, is just one mark there. Your x coordinate, your x there is negative 2, like we said there. And then calculate the values of Q, A, and Q. There is our A and Q. So we are saying your y is equal to ax squared plus q. And we have already seen that from our diagram that your q is an 8. So y is equal to ax squared plus 8. We have that one. Now to determine the value of a, we substitute any other point which is on the graph. So another point that we see on the graph of G, we can make use of this one, we can make use of this one. Let's substitute S, 2S to 0 there. This is your X and this is your Y. So your Y there is 0 is equal to A. Your X is a 2. So it's 2 squared plus 8. This is 4. So it's 0 is equal to 4A plus 8. Take your 4 to the other side. It's a negative 4A is equal to 8. Divide both sides by negative 4. Your A will be negative 2. So the graph of G there is Y is equal to negative 2x squared plus 8. Look at that graph of G. It's negative, that's why it's facing downwards. And then the y-intercept there, the value of Q is at 8 there. So we are saying here the value of A is a negative 2 and the value of Q is an 8. Writing the equation in full is negative 2x squared plus 8. Though the question did not really ask for the equation, but we'll need it later. Determine the equation of f. There is our f, and that is f of x is equal to mx plus c. Let's write it here. Y is equal to mx plus c. And we agreed that time that the value of c there is 8. We are given there in the diagram. So it's y is equal to mx plus 8. We substitute another point now, which is on that line. Do we have a point? This is f, and the other coordinate there is negative 2s to 0 there. That is the coordinate for r. Substitute that coordinate into this equation so that you get the value of m. Your x is negative 2, your y is 0. So it's 0 there is equal to m. Your x is negative 2 plus 8. So we are saying 0 is equal to negative 2m plus 8. Take your negative 2 to the other side. We have positive 2m is equal to 8. Divide both sides by 2. Your m is equal to 4. So the equation there is y is equal to 4x plus 8. Y is equal to 4x plus 8. And then from there, use the graphs to determine the values of x for which this one is asking for the point of intersection. This is the point T and point R. Those are the values where F is equal to G. Normally, when we determine the coordinates for these things, we ask you to equate the two graphs. But in this case, there is no need for you to do that because the coordinates for intersection, they are given. X is equal to 2 here, and for this one, x is equal to 0. So we are saying f and g are equal when x is equal to negative 2 and when x is equal to 0 there. We got these 2 points from the graph. And then looking at this one, interpretation, x multiplied by g of x is less or equal to 0. The interpretation there is talking about the areas where the signs are different, right? When it is less than 0, it is saying when the signs are different there. Now we need to look at the diagram and determine the areas where the signs are different. I'm going to use a table here, G, and then I have X, and then I have my number line. On my number line, I want the critical points. I have a negative 2 because G is changing from being negative to being positive. So I'm starting with A. It's a negative 2. And then I also want this at 0 because the X changes sign there at 0. So I'll write my 0 there. And then the last one is at 2 because my G changes from being positive to being negative. So this is 2. And then determine the signs for these two functions. To the left of negative 2, x on the number line here, x has negative values. From negative 2 to 0, x also is having negative values. From 0 to 2, your x is now having positive values. From 2 to infinity, it is also having positive values. Now, let's look at G. Our G to the left of negative 2, that is to the left of negative 2, the G is below the x-axis there. So our G is negative there. And then from negative 2 to 0, from negative 2 to 0, our G is now above. So it is positive. And then from 0 to positive 2, it is still positive there. And then from 2 going to infinity, it is now negative. That is, it is now under the x-axis. So we said for this question, we are looking for areas where the signs are different. Let's look for those areas where signs are different. It's between negative 2 and 0. You can see that the two signs are different. And then after that, there is negative and positive. So it's from 2 going upwards. So we are saying the signs are different there. From negative 2, there is an equal sign there. So it's less or equal to x, less or equal to 0. That is the first phase there where the signs are different. And then here the signs are the same. So the area we want is this one from 2 going to positive infinity because the signs are different here. So it's x is greater or equal to 2. That is the solution for this one. So the solution is saying when x is between -2 and 0, and then O where x is greater or equal to 2. That is your solution there. And then the last question, the graph of h is obtained when g is reflected along the line y is equal to 0. Do you remember that line? There we are. This is the line y is equal to 0. So the line y is equal to 0, we are talking about the x-axis. So g is reflected about the x-axis. Let me draw the sketch of g there. This is my g. This is my g. Here we have a -3, we have a 3, we have an 8 there. But now, when we say it has been reflected along the line y is equal to 0, we are saying it has been turned upside down. So after the reflection, this is the new function that we are going to have. It has just been turned upside down. When it was reflected like that, the coordinates for the x-intercepts do not change. It's just this one. It was +8. It is now a -8, right? The original equation, remember the equation, it was y is equal to -2x squared plus 8. It was your g of x was equal to -2x squared plus 8. Now, when it is reflected along this y is equal to 0, it was negative. So it had a negative here, but it is now positive. So your h is going to be equal to 2x squared. But it is no longer cutting the y-axis at positive 8, is now cutting at -8. So that is -8. Another way of doing this is when it is reflected, look at this. We have a coordinate -8. If it is reflected, it goes to, is +8 here, so it goes to -8. So it just changes sign. So we are saying your g of x here has just changed sign, -2x squared plus 8. We have just changed the sign. So this is now going to be negative is 2x squared, negative and negative there, -8. So this is now h of x. Well,